Hi, my name is Prakash Gupta, and this is my Physics 2212 Lab 2 video report. Let's jump in. So, beginning with the overview and purpose, this lab exercise involved an investigation of magnetic forces and magnetic fields, and the principles at play included superposition, of course, magnetic forces and fields, measurement, and modeling. There were two sections, which was our experiment and our simulation. Starting with the experiment, we used a phone app magnetometer to determine the magnetic field strengths at various locations relative to our bar magnet. Actually, more accurately, we could say that we used the measurement from the at set magnetic field strengths to determine different positions about our magnet. You can see a screenshot of that magnetometer app on the far right. Um, This data was then entered into a Excel spreadsheet that was provided to calculate some different pieces of information. And that includes this graph that we see here. So we're supposed to assess what of these four statements were accurate. We do have varying levels of accuracy, and this can be due to some human error as well as equipment error. But when the magnetic field is far away, it was near zero in that that's true because there was little impact from the magnet when it's far away. This follows from the magnetic field and magnetic force equation. As it moved closer, the magnitude increased, so that's false. And then the position of the magnetometer has no effect is definitely wrong. And as it moved closer, it increases, which is again the opposite of that original statement that we said was false. Moving on, we can talk about the simulation. So here, we wanted to find the magnetic field strength and direction at several locations, and we can see the arrows here, which luckily align with what we expect the magnetic field lines to kind of look like. We can see here that these are coming out of what must be the south end into the north on both sides, which is what we would expect. We can also see here the dipole magnetic field formula that was to be created. And this is pretty straightforward. It is literally just the magnetic field equation. Moving on, we have some questions and sources of error. So what if, in the experiment, you oriented your setup so as to compensate for the magnetic north? What if we hadn't done that, but instead laid the meter stick at some intermediate angle? How would the results have changed? So the measured magnetic fields at all of the locations would have been a bit different, either stronger or weaker, depending on our orientation and how aligned we were with the original magnetic field. And that's going to follow with our rules about the cross product. We also wouldn't be able to, in our setup, we made some presumptions based on that alignment that allowed us to separate the X, Y, and Z components of our own magnet with respect to our own magnet. That's going to be different and going to be even more impacted by the magnetic field from the Earth in the other direction. Um, and then for the next part, what if, imagine we had two identical magnets and we redid the experiment using both of them stuck together end to end? How would we expect our measurements to differ? And we wouldn't expect there to be a tremendous amount of difference here. And that really follows from the fact that when we line two bar magnets up end to end, they really become one, they can be treated as one single bar magnet. This also kind of follows from this idea of subdivision, where if you cut a bar magnet in half, you get two bar magnets, which are weaker. So in line with that change in magnitude, we would expect there to be a higher strength. Um, Regarding some sources of error, as mentioned before, precise measurement of location was a little bit difficult for me for the experimental setup because all I really had on hand were imperial tape measures. And then the conversion from imperial to metric can offer some impreciseness. There's also heavy fluctuation in that measurement app. If you recall before, it was pretty shaky. Um, but that's one source of error. There's also human error in shakiness of my hand and moving the magnetometer around. But thank you so much for your time, and that is the Physics 2 lab report.